Okay, hello. Good. I'm on. Good to see you here. It's a pleasure to be here at the Autism One conference. Dr. Death talked about methylation status and the pathways that were related to redox potentials inside the cells. I'm going to continue on a little bit with this, but before I start, I actually wanted to present to you a little bit of research that I have done in the autism community, or on the statistics for autism, since this is an autism conference. And I'm a physicist. I have a degree or PhD in atomic physics, which means I know how the atoms work and how they fit together to make molecules and such, and the rules that apply to that sort of thing. And so I can do statistics. And so I looked at some of the autism statistics, and I didn't believe it, so I started to do them a little bit myself, and realized that we're probably in trouble if we don't get these trends changed a little bit. And this is the ASD prevalence in the U.S. per 1,000 people. And I was only able to find good data from the CDC from the years about 2000 to 2012, and then nothing else. However, there's been some informal, unscientific data that has shown that this is pretty on track, and that we have not varied from this exponential increase so far. What this means basically is that in the year 2000 we had 1 out of 150 kids, or people, that were diagnosed with ASD. In 2010 that dropped to about 1 out of 75. This year we're at about 1 out of 50. And going forward, if this trend continues, then we're going to be 1 out of 40 in 2020. And when my grandchildren are growing up, about 1 out of 20 children will be diagnosed with ASD. In 2040, 1 out of 11, my great-grandchildren then will live possibly in a world, if this trend is not corrected, where 1 out of 3 or 1 out of 2 people will be autistic. So we can see very clearly how important research is in this area, and how much we need to affect this area, and what causes it. Well, why in the world are we seeing a growing trend in autism and in the spectrum? Well, is it a genetic factor? Well, that's a possibility, and I've read a lot of papers on this. The predisposition is possible for a genetic predisposition, to affect autism, but it really doesn't explain this growth, because the population growth is about 1.2% per year, and autism growth is six times that amount, at 6.7% then per year, according to the growth. So we really can't explain autism in the sense that it's a purely genetic phenomenon. What really shines out is that there are environmental factors, aggravation, for example, and the early onset of ASD from different chemical exposures and toxins and medications is pretty well established. And then the correlations to symptoms and heavy metal intolerance and such can be replicated in studies in animals, in labs. So we know that chemically induced autism is very much possible. And possibly then these environmental factors are the most important. So where's our hope? Where does our hope lie? I believe our hope lies in some of the people in this room, to tell you the truth. Because the knowledge base also is following an exponential growth curve. In 1665, that's only 10 generations ago, we only had one publication. But by the way, publications follow this exponential curve too. So it's very interesting. Almost everything does with the society. And it was called the Philosophical Transactions of a Royal Society. And then 1900s, there were 250 journals and 7,000 articles being written per year, and people like Einstein and Max Planck. I'm a physicist, so those are the people that I think are heroes. In 2013, this year, 23,000 journal articles are being written. That's 1.4 million journals are being written, 1.4 million articles, and that represents over 10 million months of scientific study published per month. This exponential growth of knowledge is really what I think will enable us to find the solution. The unexplored possibilities that we have stretch into the horizon. A scientist who believes he knows everything is not really a scientist and has given up the joy of science. The joy of science is a discovery process. And out there in this vast array of possibilities, the answers do lie. And that is, I believe, where the hope of finding solutions lies. So there are thousands of scientists and practitioners, many of which I've heard and seen here at the Autism Conference, that are searching for answers. These thousands of people are spending countless hours in trying to understand what autism is, what affects it, and how we can affect it, and how in a positive way. Of course, environmental factors are being cited quite often as being some of the major factors that are causing this to occur in our society. What if we were to be able to tap in to this research, all of this research? Research projects from different universities and such that have a sway on autism. Now, there are a lot of different opinions here, and there's a lot of different people doing research, and there are a lot of at times very animated discussions on these very issues. But we all are trying to find a solution, and we all need to find a solution. So how do we do this? Now, this was a thing that was set before me last year in the Autism Conference. I came out of this conference almost in tears. I was in tears because I realized that the current medical system will not be able to answer the questions in the time allotted. And so we need to be able to accelerate this process in some way on a global scale in order to be able to handle this problem. And the millions of family members also of autistic children, and the many more to come, are also looking for answers. And I think that's also where a lot of the answers lie. I'm here because some autistic mothers grabbed me by the necktie and said, "You're coming here to this conference," and explaining to them what these technologies that I've been developing or that I've been involved with are all about. So we formed a global scientific network called Spark Global Research. We've spent a year and many hundreds of thousands of dollars trying to develop this platform for researchers. And what it is a web-based secure network of researchers. The researchers can list their projects there. They can also decide whether they want to privately collaborate or share that information if the intellectual property is available to the public in a showcase, sort of like a TED Talks showcase, and then interact with people and the interested communities if they so choose. And this is all an open, very open forum, and it's by choice. There's nothing that we are trying to kick off of this forum right now. But we are building this so that major universities can and researchers can also participate in this forum, in this platform. We have yet last year we have Zach Bush here with us, and he and I sat down and our visions came together just like a beautiful puzzle, and we started this project. So this will be available coming this year, and and we expect it to grow then exponentially also, faster than autism. So great. So some of the things that we've found already in this group, in this loose group of people, are carbon compounds that can tie the filtering, tie the leaky gut together, and cause that toxins can be eliminated from the system. We've also found safe, effective redox complexes that can release toxins. I'm going to be talking about these. Can release toxins from our system through NRF2 activation, and they're effective to enhance the master antioxidants and the glutathione pathways and the methylation pathways and all the other pathways to normalize redox potentials in the vital fluids of our cells. These things are ongoing. I can't even mention some of the other things that we're seeing. This is important to autistic communities because the detox channels through the gut have to be opened up. We've shown that these actually do open up many of these pathways. They get the toxins into the blood, they get them through the liver and out of the small intestine, and help to reduce inflammation in the small intestine so that this process is not blocked. And so this is a very, by the way, this is sort of new data. We're finding that the NRF2 pathways are very actively affected. So this is very exciting. It's the basis, actually, behind all oxidative therapies. So ozone therapy and photonic therapies, for example, and hydrogen peroxide therapies, and hyperbaric oxygen and pulsed EM frequencies, and chlorine dioxide and other oxidative compounds that cause oxidative reactions inside of our body actually are all part of the same mechanism. The mechanism is redox signaling. They get to it from very different angles, but they actually try to release some of the oxidants into our system. Now, what in the world what do I mean by that? We were talking about redox state before. In our biological organisms, we're made out of tissues, and the diverse and complex structures of life are interconnected tissues. Tissues are interconnected cells. Cells are interconnected molecules. And what interconnects them, the complex molecules, is all of these water molecules. Water is oxidized and reduced. Salt water actually is the basic fluid of our body. We can oxidize it and reduce the salt water to create different things like hydrogen peroxide. The body does it in large amounts all the time. So why is this important? All of the molecular players inside of our body are in harmonious orchestration. And it is absolutely fascinating, and we will never understand it all, how the harmonious orchestration of life takes place. And these interconnected molecular players, every single one of them exist in salt water. All biochemical reactions exist in salt water. And this redox signaling is the conductor of this orchestra. The redox state of our fluids and the interconnection between all of these vital fluids actually becomes the conductor of the orchestra. And it's all orchestrated by oxidation. Now, I'm an atomic physicist, so I'm going to go into oxidation states just a little bit here, if you don't mind. Oxygen's an interesting kind of a molecule. Here's what it looks like to us atomic physicists. it has these two unpaired electrons out there in this state. And those unpaired electrons love to grab other electrons. So these things become very sticky. Oxidation is when electrons are grabbed off of other species and included into these oxygen pairs and other oxidation states. Because oxygen can indeed take on other states where these free radicals or unpaired electrons play a very important role, such as the superoxide anion. One of the things we've been able to do is stabilize, we believe, this superoxide anion to keep it in solution. Peroxides and hydroxyl free radicals and such also are part of this. These are what they call the reactive oxygen species. When we talk about the oxidative state of our fluids, these are the things that actually are causing the shift in oxidative states to take place. Superoxide dismutase, as you've heard of this, and glutathione reduce some of these things to their normal oxygen states. Ozone also, 3 combinations of oxygen, is able to undergo oxidation state, several different types of oxidation states. And so it's interesting to study these things. Water molecule itself is made out of hydrogen. Hydrogen is actually earlier in its genesis than oxygen. Oxygen didn't appear in the atmosphere for a while. So hydrogen actually is more fundamental in some ways to life than oxygen is. And it also has oxidation states. But welcome to my world. 1 trillion billion of these molecules will amount to only 1 drop of water. And they're all moving around at many thousands of miles an hour, and they're very, very tiny. And it's kind of exciting. It's interesting to see, how life can be made out of these vibrating and bouncing little things that are developing quantum physics. Water also clusters into different types of growths, cluster growths, which also affects the different types of absorption that takes place inside of our body through the membranes. So here's the takeaway from this, okay? In a healthy cell, we have what they call redox homeostasis. That means that these ROS, the smoke here, that comes from the mitochondria. The mitochondria is burning sugars and burning fatty acids to create energy, ATP. But along with the energy, it's also creating these reactive oxygen species. And we thought that they were byproducts and should be eliminated. The body has a wonderful way of eliminating them through these antioxidants, and these antioxidants then eliminate and return these oxidative components back into water and salt, basically, and oxygen, nascent oxygen, things that don't that harm us. And then there's electron donors that just kind of help it along through NADPH complexes and such. But anyway, if the cell is healthy, this is the state. What we've learned during the last 20 years is that these oxidants perform a fundamental signaling role inside of our cells. That means that if things get out of control, if our cells become damaged for any reason, almost any reason whatsoever, a toxic response or physical damage or imbalance in proteins or even malnutrition, these damaged cells indeed will, or even hypoxia, lack of oxygen. These cells will become damaged and get into a state of oxidative stress, which means that they're producing more oxidants than they are reductants. What does that mean? That means that the reduced glutathione goes down because it's oxidized. And the methylation pathways then also are subdued, and all of these things are subdued in the cell. And the genetic buttons that it presses are related to repairing itself. It needs to become, again, balanced and retain this homeostasis. If it does not, then it, in about 2 hours, will kill itself. What are we talking about here? We're talking about healing. This is healing on the cellular level. All healing then is a response from oxidative stress. And so these oxidants are very important, and they can stimulate some of the genes that cause us to heal quickly. And antioxidants and oxidants then are now known to be absolutely fundamentally connected partners in this process. We cannot get rid of the oxidants. We can't get rid of the antioxidants. In fact, these oxidative therapies actually try to increase the amount of oxidants inside our body, and it's kind of counterintuitive. But I'm going to give you a few study results that I think that are absolutely fascinating on this sense. On the regeneration of tissue, we talked about damage of tissue. Regenerative processes also involve this redox signaling. Here's a tadpole. If you cut the tadpole's tail off, it'll regenerate the tail, right? Well, what role does oxidation play in the regeneration of the tail? The bottom shows hydrogen peroxide, or an oxidative compound concentrations inside the regrowing tail. When you first cut it off, you hardly have any oxidants at all, no ROS. But as it starts to regenerate along the fastest growing parts of the tail, you'll start to see high levels of oxidation. And these high levels of oxidation then are actually causing the regenerative process to take place, or we think that it's caused, or maybe it's just the effect. And so they tried this again, and they put antioxidants in there to get rid of the oxidation. And here are some of the antioxidants. Some were better than others, but when the antioxidants were in there, the tail did not regenerate correctly. So antioxidants actually stopped regenerative processes in the tadpoles. And we're starting to learn that this mitochondrial ROS is required. In fact, it's one of the primary things needed in order to regenerate tissue. And this is really exciting. I mean, what we're talking about is actually a handle that we have right into healing. The problem is that the generation of these reactive oxygen species is inside the cell. And we haven't been able to work with this reactive oxygen species because it disappears in a millionth of a second inside a cell. And it only acts very locally. So James Watson, a PhD, he said in chemistry, oxidation, and reduction, that the body cells can't survive without making both oxidants and antioxidants. He by the way, also determined the structure, or helped determine the structure of DNA. And he says there's a delicate balance. And physical exercise, he says, prompts the body to make large numbers of oxidants. And he believes that this is the way. So you go out to the gym and you start to exercise, and these oxidants then create the regenerative processes inside your body. They certainly regenerate the muscles that have been damaged because of the exercise that you can feel. And so these other therapies also are targeted toward increasing the amount of reactive oxygen species inside the cells. Infrared light, for example, electromagnetic radiation in some frequencies can stimulate the production of reactive oxygen species inside of our cells, and also stimulate the regeneration processes in the same sense. I've seen, for example, electromagnetic pulse therapies that can regenerate a chicken wing after it's been cut off, and things like that. This is remarkable stuff. Inside of our bodies, when there is an imbalance in these oxidants, like I mentioned before, the cell tries to do everything it can possibly do to restore the balance. It calls in the immune system to get rid of whatever pathogens may be irritating the tissue. It also, if it cannot repair it, kills the cell. and then it is replaced again by healthy normal cells. And so that we see that this regenerative process again is facilitated by the oxidants that are in our body. Well, this is all nice and good. What do we do with it? We have inside of ourselves at times, in fact, in autistic kids, cases where there's chronic oxidative stress and there's no way to get to it. How do we flip the genetic switches? How do we flip the switches that will help the cells to rebalance this redox potential inside them? And one of the ways possibly would be to infuse a balanced redox formula back into the cellular tissues. Then possibly it would increase and I'm saying possibly, but I'm going to give you the real stuff in just a minute here. Increase the possibility of these cells to actually recognize that there's damage and start the process of repairing and replacing, as we've explained before. So in autism, what are the physical manifestations, the physiological manifestations of autism? And I looked up a few, and I'm not at all an expert on this. But abnormal brain physiology, we have wonderful talks here last year on this. Myelin damage and liquid pockets in the brain and overstimulation of emotional centers, and abnormal intestinal physiology such as inflammation and leaky gut and those sort of things are manifestations of chronic oxidative stress that hasn't been dealt with, and that is causing damage inside of our system. They're natural, normal ways that the cells can deal with these, but they are not able to. The field of redox signaling actually is expanding. We're starting to gain a lot of knowledge. There are journals, for example, that talk about this. There have been Nobel Prizes won by people who have looked at redox signaling compounds in different cell receptors. And by the way, these same compounds that are used in redox signaling are antimicrobial. They're the same things that kill bacteria from our immune system. In fact, they're the weapon of choice. Basically, if it doesn't kill the bacteria, it doesn't get killed. And so it has to be very effective. These things have to be very effective against bacteria. So we have some very interesting things to deal with. My insulin also producing processes involve these molecules and regulation. So I mentioned some of these things before. I'm going to go forward because I'm running a little bit out of time and give you what my research has been in the last 10 years in the last few minutes that I have here. The cells, process the sugars and oxygen. About 90% of it is processed through the mitochondria, which produces the energy, but it also produces these exact components. The mitochondria, through the electron transport chain, has a very interesting way of producing these things. Suppose we could produce them outside of the mitochondria. And suppose we could produce these things in a bottle, in the laboratory. We've been able to do so. We've been able to stabilize a perfectly balanced set of the same redox signaling molecules that exist inside normal cellular fluids and that are produced by mitochondria and put them inside of a bottle. Now, the first time that I heard about this, this is not my technology. It actually happened by accident inside a laboratory. I said, this stuff I wouldn't touch with a 20-foot pole. First of all, because I had been indoctrinated with the old, oxygen free radicals are bad sort of thing. It took a while for me to kind of come around. And then I started to realize through this field of redox signaling that these things actually are very fundamental. not to just any form of life or to our form of life, but to every form of life that exists on the planet. Plants use these processes in order to regenerate. Animals, all forms of life on Earth use these processes. This is absolutely fascinating thing. And so the trade name is for this stabilized product now that's on the market. It's called Asea, and booth 41, if you want to learn more about that. I'm not involved in the business part of it. So here's the news. We can create these redox compounds that help the cells detect damage, regenerate tissue, balance the chemistry, and it's completely biocompatible and bioavailable. We have done 25 years now of studies, both in vitro and in vivo, and human studies that have shown that there's absolutely no toxic response whatsoever in any type when cells and tissues are exposed to these compounds, to this compound. It's perfectly safe, unlike hydrogen peroxide and ozone and other things which may be irritable and cause problems. So here are the potential applications of this. We can actually target oxidative stress, possibly reduce it, normalize the immune response. That means bring it up if it's low and bring it down if it's high. Hormonal response, and we've seen this before, incredible things in a hormonal response. By the way, when you add this to a cell culture, even senescent cells that have lost the ability to receive hormones regain that ability again. Optimize metabolic pathways, open detox channels, facilitate tissue repair and damage detection, and optimize then the cellular function. I mean, what can these things not do is almost the question here. So I'm going to go through a few studies we did. These were studies about 10 years ago. We used in vitro, we used lung cells, endothelial lung cells, small endothelial lung cells, and we put them in solutions with this compound. We saw absolutely no indications of toxicity or inflammation, no cytokines. It actually enhanced the glutathione production and superoxide activity in these cells by, and this was incredible, in some cases 1,000%, 400% in other cases. Glutathione became superglutathione inside these cells. And the ratio of reduced to oxidized glutathione went up. Reduced to oxidized glutathione, went up. Correct me if I stutter or get lost here, please. It also increases hormonal sensitivity. TNF-alpha, for example, cells that were non-responsive to TNF-alpha became responsive again to TNF-alpha and underwent apoptosis. It reverses senescence, and I mentioned that before. Here, up to 20% plasma concentrations had no toxic effect. I'm not going to explain this now, but the toxic effect is when you see those the translocation of these NF-kappa Bs into the nucleus on the right. That's our positive control. In fact, in animal studies, 20% of the blood plasma was replaced by this compound with absolutely no toxic response for the animal. They were happy. In fact, too happy. The researchers didn't like it because they were running around too much in their cages and stuff. We've also seen the upregulation of NRF2. And this upregulation effect lasts for about 120 minutes. Again, these are looking in endothelial cells, the lung. We verified that both glutathione production and SOD production were upregulated. And again, this antioxidant efficacy went up by over 4 times in these cultures. So this was very encouraging to us. Here we found something that was absolutely non-toxic and yet could touch all of these oxidative processes, or normalize, I should say, the homeostasis inside the cell, we believe. They also killed microbes, by the way, in under 30 seconds for all tested bacteria. Even the over 30 resistant strains were killed instantaneously almost by these compounds. But there was no effect on the beneficial flora that is in the gut. We could drink bottles of this stuff, literally, and have no effect on the microbiome. So cell cultures also we found in these cases a summary of everything we've seen so far. It accelerates the kill rate, or apoptosis, only in the damaged cells, not in normal cells. Normal cells it leaves completely alone. And that was just incredible. So it targets only those cells which are under a state of oxidative stress, and it leaves the rest of them alone. That was where we thought, hey, we've got something actually that is groundbreaking. And that's also the point where I decided that I was going to devote some of my career, not only to the science behind this, but also to get it out to the people who needed it. We need more people out there that are scientists that are willing to take that step. So we have 20 years of data in mice, rabbits, and dogs. Mice run 29% longer to exhaustion when they fed this stuff. There's metabolic shifts in these animals and in humans, by the way, that are very significant. Antioxidant capacities increase. The glutathione ratios, now I listed it the other way around. The oxidized glutathione actually decreased, which shows that we're actually doing some antioxidant activity in the glutathione. Imagine this: you're putting oxidants into a system and you're getting antioxidant effects coming out. This was exciting to me. Okay. Actually, it's very understandable when you look at the science, and some of you in this room actually understand what I'm talking about. So in 18 years, this is old, we have all the preclinical stuff done and gene maps done for full genomes for animals done here. No lethal dose was found, complete lack of side effects in animals again, and no abnormal histopathological effects in all tissues and major organs. It was as if it was salt water. But it certainly is not. Because where there's oxidative stress, there are very notable differences. This means a lot. It means that we can take it and it'll target the oxidative, the stressed tissues in our body. So clinical studies now in humans on the supplementation in humans has shown this. We have 5 major clinical studies, some involving more than 160 people, complete blood work and comprehensive analysis. We've looked at about 260 metabolites. That's gone up to about over 300 metabolites now. We've seen 60 have changed at a very good correlation. In fact, I think the p-values for this are 0.0002, something like that. And lipids and fatty acids and intermediates are the things that we were looking at. Pharmacokinetics, by the way, was also run with these markers, these same markers, and we found that there was absorption in most all tissues, and shifts in metabolites lasted between 30 minutes and 24 hours. We saw metabolites shifting for 24 hours. And this is after taking 1 4-ounce dose of this in the morning. Here's some of the human data. Each one of those points represents the 260 metabolites we looked at, plus. And here is what happens after the humans drank. Humans. I have to get off of that. You know, I hate to be such a scientist. I'm in the human condition too. We all are. We ought to remember that. So these metabolic markers are shifted. And metabolites in the Asea PK studies, again, shifted, and these profiles shifted over time for over 24 hours. So we know that it's getting into the system, it's doing what it should do, and it's having a great effect. Now, I didn't believe that it actually would work after all these studies were done, at least the early studies were done. I still had a lot of doubts. Before the pharmacokinetics was done, I said, well, is it really even absorbed into the system? Can it even get into the system? Does it have an effect? Well, one day, my wife, who came with me to the conference today, and I love her very dearly, cut her finger, and it was bleeding. It was about a 4 millimeter deep cut. It was bleeding quite profusely, and she couldn't stop it. And so I said, well, honey, would you please put your finger inside some of this? Maybe it'll work. I don't know. She put it in there. The bleeding stopped immediately. I tell this story because some of the clinicians have actually saved lives because of they were able to stop hemorrhaging in their patients with this substance. The bleeding stopped immediately, and the blood did not coagulate, but it didn't diffuse either. It just kind of sat there. And I said, what in the world is happening here? And as I was staring at this, my wife, since it was antimicrobial, she didn't have to, disinfect it or anything. She just went over and started cutting vegetables again. And in 4 hours, it had completely closed. And the next day, there wasn't a scar. And so at that point, I realized that we had something absolutely incredible, and it was doing what we thought it was doing, and that is normalizing redox potentials in these tissues, accelerating healing, both inside and out. And I only needed my wife's finger as evidence, and all these. In fact, I find that to be true. One of my colleagues, for example, had no idea, and I went through the science with him back and forth. No idea that it could have such an effect. And I said, okay, it's safe, try it. And so he started to drink it. And he said, what in the world is happening to me? He was detoxing. He had been smoking for 20 years, and all this tar and guck were coming out of his mouth. The nature of his bowels had changed. And he felt a lot better. He said that his concentration improved, and a lot of these things happened. And he said, what in the world is this stuff? So 20 years of science didn't convince him either. He actually had to experience it for himself in order to realize that it actually is working. So anyway, we have this out as a supplement in the field. About 50,000 cases that we understand statistically have shown beneficial reports. And it's one of the best oxidative therapies, I believe, that we have. It mediates and regulates all the mechanisms that restore the redox balance inside of our vital fluids. And it normalizes our cellular functions. And to the autism community, especially those that have inflammation and oxidative stress that causes all of this irritation, it has been beneficial for many people. And so that's what I'd like to leave you with today. And I thank you for coming and listening to me here during lunch. All right, well, I don't know if nobody's here to give me direction here. Do I have a few more minutes for questions? I have 5 minutes. So if I could, I'll answer some questions, and I'll repeat your question if you don't mind for everybody.
If I heard you correctly, I think you said that it's antimicrobial, it kills microbes, but it doesn't damage any of the beneficial flora. How does the body make that distinction, or how does the substance make that distinction between a beneficial microbe and a not beneficial?
Yeah, as far as we know, the question is, how does this substance, which is just made out of very simple oxygen components, reactive oxygen components, differentiate between the healthy gut flora and harmful pathogens? And the answer is, the body's figured it out. The body knows how to protect these pathogens. I mean, protect the beneficial gut flora. I'm so sorry. The beneficial gut flora from these oxidative compounds, especially those produced by the immune system and such. And they figured it out somehow. So it's not the substances that are doing it. It's that we've had it around since the beginning of life, and life has figured out how to deal with it, I think. Yes.
I think I've long felt that the superoxide, I've always been concerned about antioxidant therapy because it looks to me like the superoxide is necessary to make sulfate from reduced sulfur sources. And I think that, and also you need the ATP to combine with the sulfate to make the form of sulfate that can actually be moved around. And when you get sulfate deficiency, for example, in the gut, you get the leaky gut. You get sulfate deficiency in the blood, you get issues with blood flow. And sulfate is also needed by the immune cells to fight off infections. So we have, I think, a systemic sulfate deficiency problem today that's an underlying driver behind all modern diseases. And I think your oxidation therapy is helping to correct that because, for example, ascorbic acid, in the presence of homocysteine thiolactone, you can get sulfate out of superoxide. So I think that might be an explanation for why this works so well, and also maybe why the beneficial microbes are protected, because if it generates the sulfate to heal the gut lining, then you don't need, the pathogens are there because of the inflamed gut lining that doesn't have enough sulfate. So you correct that problem, and then you can get rid of the pathogens. So that's just some thoughts that I have. This is great stuff. Thank you.
Oh, thank you very much, Dr. Sena.
Thanks. Is this intracellular healing? And can you speak in because it would help the brain from what I can tell. And I'm actually looking for something because I've got a 20-year-old and she's learning how to drive. And she's had 12 lessons. And she's still missing stop signs, and she's still going way out of her lane. And also what's worse is when I pick her up from work and I ask her if she wants to drive, she's too tired. So I need support for the mitochondria, and she does have the mitochondrial disease.
Oh, well, first of all, I'm sorry. I know how it is to have people out there on the road, and that's very concerning, children on the road.
Well, yeah, and I'll speak one more thing, and I don't know whether this is happening in other counties, but our county, you do not have to have a state road test. So right now, she could get her license.
Okay. Well, as far as the substance is concerned, it does pass through the blood-brain barrier. In fact, one of the things in traumatic brain injuries, we've learned that there is regeneration of brain, especially the brain material that's under what they call oxidative stress caused by lack of oxygen. Now, in the traumatic brain things, we've seen very, very clear indication that what happens actually is that the brain doesn't die from lack of oxygen. The brain cells start to die because the apoptosis process takes place from oxidative stress. And oxidative stress causes the majority of it to die. If we can stop that oxidative stress process in the neuronal materials, we can actually not only stimulate possible neuroregeneration, But we can also stop the processes that are causing the brain cells to die. And we don't have studies on this, but the anecdotal evidence from people is such that I would like to have this in every single emergency room for traumatic brain injury. It is getting into the in the brain, and it's helping process. Yeah, good news is it takes time, but it happens. And you need to get rid of the oxidative stress first in order for the regenerative process to start to kick in and really make a difference. Yeah.
Hi there. When I've shown people the ingredients of Asea, they say, well, this is just salt water. So
Yeah.
how do I explain that?
Have them try it. It took me about 2 seconds to figure it out. It wasn't salt water when I first saw it. I just smelled it, and it's definitely not salt water.
So smelling it is the
Yeah, they just, people who say that actually are extremely ignorant. They haven't even tried the product, and they're just believing so I don't know how to stop those rumors, but there's certainly no basis in fact for them, Yeah, I'm in fact, it just amazes me what people come up with. In the literature, I'm the devil incarnate, or I'm like a god, and I don't know if I'm just me. And so it's just amazing what happens as things get out there. But this is true. It works.
Have you been able to determine a dose-response relationship for any particular process or pathway?
I'm sorry?
A dose-response relationship, in other words, the amount of material versus the response.
Yes, okay, the amount needed for a response, yeah. We have mostly through the human studies and through about 20 years of people using it, and it's about 2 ounces twice a day for the average healthy person to get a response. You can take up to about 8 ounces twice a day if you have very extensive tissue damage in your body. Yes. Actually, the amount you give is proportional to the amount of oxidative stress that exists inside your body. It doesn't seem to do very much to the healthy normal cells, but it does target the stressed tissues. And so if you have a lot of stressed tissues, I would suggest, however, that since it does open up the detox pathways for people who may be sensitive to detoxification, that you start with small amounts, like half an ounce twice a day or so, and then work up over a week's time to see what happens. Some people that have major tissue damage, major problems, actually will start to get flu-like symptoms as their immune system starts to attack the damage. And so we've seen immune system activation actually start or initiate in the cases where they have lot of tissue damage, especially in the case where the tissue shouldn't be there. And apoptotic processes start to take place. But that I hope that answered part of your question. If you have more, I'll be glad to talk to you after this
Dr.
meeting.
Samuelson, I have a question. You mentioned that currently there are times in an emergency room setting where Asea is being used, life-threatening situations or maybe even in brain trauma. How would you administer Asea in those situations, and in particular with those that are dealing with brain trauma?
I do not.
Well, how is it being done?
That's the individual decision of the doctor who's administrating that, and I have no control, or sometimes I don't even they don't even listen to me. So,
well, are there options outside of drinking it where people could administer it safely?
Yes. In fact, you can put it on any type of tissue, organ, or whatever we found, so that there's absolutely no banned areas. You can put it in your eyes. This is really interesting. You can drop large amounts of it into your eyes, and no irritation takes place. That's because the U.S. government does not allow us, unless we spend about $1 billion to use it now. Well, yes and yes. You know, we have to be careful about those sort of things anyway, and I would be very, very careful before I would do anything along those lines. Yeah.
Hi there. I know I'm going to go home and try to explain this to my husband and not remember any of it. So I was just wondering, is there any literature I can take home?
Yeah, there certainly is. Drop by the booth. It's number 41, and they'll fill you in on and give you all the literature, hopefully, that you'll need. If
and
they
what
don't,
about this lecture? Like, do you
yes. Well, this should be on the program.
Yeah?
So actually, we have a PDF of the slides, and they'll be posted
great.
on the autism program, I
Great.
believe, or somewhere. Yeah. So.
Cool. Thank you.
Is there any reason, and I'm 99% sure the answer is no, but is there any reason why a surgeon couldn't apply it during a surgery instead of cleaning the wound with water, cleaning it with Redox molecules?
No, I'm not going to stop them from doing that at all.
Okay.
And it's certainly safe. But wow, it's an antimicrobial.
Right.
It kills everything, and it helps to reduce inflammation.
Right.
And increases the healing rate. So
Because he needs another surgery, and I'm thinking, like, I'm going to tell the surgeon to do that, but I wanted to check with you.
I have a few caveats there. You know, if for the doctors in the room, if you're going to use it for irrigation, be very careful that all drainage is taken place, because it'll actually heal up the wound before drainage is able to take place. Yeah. So be careful about that. You know.
Okay, I'll let the surgeon know.
All right. Very good. Thank you.